This is section 1.6, absolute value functions. So we're going to talk about and learn a bit more about absolute value functions. This may be a review, it may not be. So an absolute value function, we know it, writing it as f of x equals the absolute value of x using those bars. But it can also be defined using a piecewise function. So what it is it's actually two pieces. So on a graph, we have the left piece for x is less than 0, where y equals negative x. So we have that line with a slope of -1 coming down. So that gives us this one part. And the other part is from, on the right-hand side, so from 0 on into infinity, it's y equals positive x. So that's what gives it there. So notice that there are two different pieces, technically, when we write that. So let's describe all values x within or including a distance of 4 from the number 5 using an absolute value. So in order to do this, we're going to need to know the rule on how to write this. So the way we do that is we take x minus our target, the absolute value of that, and then you're going to pick whether you're doing it equals, greater than, less than, greater than or equal to, less than or equal to, and then your error. So how far away from the target is it? So when we're doing this one, our target number is 5, so we're going to have the absolute value of x minus 5 is within or including, so that tells me it has to be less than or equal to 4, a distance of 4. So the absolute value of x minus 5 is less than or equal to 4. It says the same thing as that English sentence. So electrical parts come within specified values of operating parameters. However, manufacturing isn't perfect, so the actual values of the parameters vary a bit. Suppose you have a resistor rated at 680 ohms, plus or minus 5%. Use an absolute value to express the range of possible values of the actual resistance. So we're going to use that same equation we used up here, the x minus target. So the absolute value of x minus, our target resistance is 680, because that's what it's listed at, plus or minus 5%. So that means it has to be less than or equal to 5% of the 680 ohms. And if we do that, 0.05 times 680, we get 34. So the absolute value of x minus 680 has to be less than or equal to 34, and that describes all the possible ranges, all the possible range values of the actual resistance. So writing an equation for an absolute value function given a graph. So right here we have kind of the base function, and then we have to find our values. So find the vertex, hk, and plug those values in. Notice we have an h here and a k here. Those represent our horizontal and our vertical shift. And then we're going to use a point on the graph to find the value of a. So let's find the equation of the graph shown below. So what I'm going to do is I'm going to start out by writing my base function, f of x equals, we don't know a, but we know that we can find the vertex, which is 3, -2. So it's x minus 3, and then plus k is going to be -2. And since we don't know a, let's pick a point and then plug it in and solve for a. I like to use easy ones, so if I like this point right here, that's the point 2, 0. So I'm going to plug it in. F of x is going to be 0, that's our y value, equals a times the absolute value of 2 minus 3 minus 2. 2 minus 3 is -1, and the absolute value of that is just 1. So we have 0 equals a minus 2. Add 2 to both sides, and we get that a is equal to 2. So let's go back to our function. F of x equals, now we know a is 2 times the absolute value of x minus 3 minus 2. So right there, we found the equation of that absolute value that's graphed. So solving absolute value equations, what you want to do is you want to isolate the absolute value term and use the absolute value of a equals b to write a equals b or a equals negative b, and then solve for x. So the basic idea is you're splitting it into two equations. One is equal to the positive value, one is equal to the negative value, and then go from there. So let's try this first one. So we have 1 equals 4 times the absolute value of x minus 2 plus 2. Want to get the absolute value by itself, so I'm going to subtract 2. So negative 1 equals 4 times the absolute value of x minus 2. Divide by 4. So negative 1/4 is equal to the absolute value of x minus 2. So this brings me to write two different equations. But the first thing to notice, actually, is that we have an absolute value equal to a negative number. Remember, by definition, absolute value is the distance from 0, which means it has to be positive. Since we have this negative here in front of the 1/4, this is actually going to have no solution. If you don't believe me, you can go ahead and split it up, and when you plug back into your original, you're going to find that those answers don't work. But in this case, we're just going to have no solution. So let's see if the other one works out for us. So we have, on this one, 0 equals the absolute value of 4x plus 1 minus 7. So I'm going to add 7 to both sides to get 7 equals the absolute value of 4x plus 1. Here we have an absolute value equal to a positive, so it's going to work. So let's split it up into our two equations. Our first one is we're going to take that absolute value, just get rid of the absolute value bars, and rewrite it. So 4x plus 1 equals 7. But we're also going to use the equation 4x plus 1 equals negative 7. Because remember, what's in here just has to be 7 digits away, or 7 units away from 0, meaning it could be 7 or negative 7. And then we just solve. So we subtract 1. 4x equals 6, divided by 4, x equals 1.5. So there's one of our answers. And then the next one, subtract 1, 4x equals negative 8, divided by 4, x equals negative 2. If you don't believe me, you can go ahead and plug those back into the original to see that they do indeed work. Solving absolute value inequalities. So find the boundary points by doing exactly what we just did. You're going to change the inequality symbol to an equals symbol to find that, and then you're going to test intervals created by the boundary points. So test to the left of both of them, in between them, and to the right of both of them. And we are going to write the interval or union of intervals satisfying the inequality in interval, inequality, or set builder notation. But for our purposes, we are going to use interval notation. So let's look at the first one. We have the absolute value of x minus 5 is less than 4. So what I want to do is I want to forget about the less than sign for a moment, pretend it's an equals. So that means x minus 5 is equal to 4, or x minus 5 is equal to negative 4. Add 5, so x is 9, or x equals 1. So I'm going to look at a number line. So here's 1, and here's 9. Since it's not equal to, we know it's going to have an open circle at both of them. Let's test a number to the left of both of them. So my number that I'm going to choose is going to be 0, because I like 0. And I'm going to plug back into the original. So 0 minus 5 is negative 5. The absolute value of negative 5 is 5. But 5 is not less than 4. So this one is not going to work. Let's try something in the middle. How about the number 4? So 4 minus 5 is negative 1. The absolute value of negative 1 is 1. And 1 is indeed less than 4, so this one works. And then let's try one outside on the right. 10 minus 5 is 5. The absolute value of 5 is 5. But 5 is not less than negative 4, so that doesn't work. So we find out that it's all values in between 1 and 9. So in interval notation, remember that looks like parentheses 1, 9, parentheses, because those are not included. The same concept is going to apply for the other ones.